Welcome to Nandira Colliery, under the administrative jurisdiction of Talcher area of Mahanadi Coalfield Limited. Nandira Colliery was started in 1962 by NCDC. As you enter the premise of Nandira Colliery, a lavish surrounding welcomes you with lots of greenery. The underground working is accessed by two number of inclines of 120 meter and 160 meter, both of which are used as a fresh air intake to underground working. Incline number 1 is also used for main travelling and transportation of material using system of haulage. For convenience to the work person, chairlift main riding system was installed and commenced from 15th August 2016. The 670 meter main riding system can be used by 200 persons per hour. Nandira Colliery is worked in Talcher seam number 1 and primarily in the top section due to optimum thickness of coal seam. Development of top section has already completed. Further development was restricted due to presence of number of fault lines. Currently deep plating is underway in WP3 VFB panels while WP panel is being prepared for future deep plating. Nandira Colliery has 3 adjoining mines, Bharatpur OCP, Balanda OCP and Atlas underground. WP3 and WP4 panels were developed nearly 30 years ago with girder wooden crossbar support system. With time, the decayed wooden sleepers rendered the effectiveness of support system, leading to the disturbance and sagging of immediate coal rope. The team of WP3 has done a tremendous job in dressing and re-supporting the whole panel for deep layering. The supporting work is done using hydraulic roof bolter. Here you will see the sequence of steps in this process. First, arranging the cooling of the hydraulic oil, checking the hydraulic oil level, opening the hydraulic lever, starting the machine. A gang of 3 to 4 people is sufficient to operate the machine. The hydraulic roof bolter in use has a reach of 90 meter and a combination of inlet and outlet hose pipes facilitate the flow of hydraulic oil to the jack. 22 mm hexagonal drill rod in combination with 27 mm PDC drill bit is fitted onto the chuck of the jack. Sufficient water flushing is provided to flush out the drill cuttings. 1.5 meter length hole is drilled in a roof for a 1.5 meter length roof bolt in combination with slow setting resin capsules. A 0.8 meter resin capsule is inserted in the hole followed by a roof bolt, which is rotated at the RPM of 200 to churn the resin capsule all along. In this process, a roof bolt is installed. Nandira Colliery has two numbers of universal drill machine or UDM, which drill hole in any direction of any length. WP3 district engages the UDM for both roof bolting and drilling of face short holes. Here you will see drilling of face holes used for solid blasting. Now you will see a complete process in a working phase starting from roof bolting. Roof bolting in 3 shifts is being done by handheld core drill machine optimally by a gang of 3 persons. Wet drilling is being practiced in Nandira Colliery for flushing out drill cuttings and suppression of dust during drilling. 0.8 meter resin capsule is churned using 1.5 meter TMT roof bolt for proper grouting. The resin grouted roof bolt that was installed can take load up to 10 to 15 ton. Such is the efficiency of a roof bolting system. After any unsupported roof span is supported, short holes of about 1.5 meter length are drilled in a working phase. The short holes are used for charging explosives, which upon blasting gives fragmented rock for mucking. Before blasting is done in slice phases, steel cog and wooden slipper combination of go phase support is tightened to avoid any strata roof issue. A go phase support is a support between a working phase and a decolled area. The short hole that were drilled in the working slice are charged with explosives in combination with specific pattern of delay detonators, followed by proper stemming or closing up the open side of the short holes. After all short holes are charged, safety measures are taken and all the detonators are connected in series, which was followed by at least a 50-meter short firing cable. Adequate whistle and guarding measures are adopted so as to ensure no persons are within the danger zone during blasting. A short firer blasts the charged short holes using an exploder by staying at the end of the 50-meter long short firing cable. The locally disturbed roof and sides of the working phase caused by blasting vibration is dressed down so as to avoid any mishap during coal evacuation using SDL. The blasted coal is then loaded by a side discharge loader or SDL. SDL discharges the coal onto a belt conveyor. A chain of belt conveyor conveys the coal from working phase to the surface. Here you see the top covering of a vertical ventilation shaft through which hot and humid return air returns from underground to surface. To provide fresh air to the workperson in underground, a main mechanical ventilator is installed on the surface which exhausts the return air. Two number of inclines serve as intake for fresh air. The process of extraction of coal by depleting intentionally allows the roof of decolled area or GOV to cave in and thereby settling the stresses in the working area. The process of caving poses a challenge of substantial risks which can be minimized by using a convergence recorder. A telltale or a convergence recorder installed in the roof monitors the roof convergence before any impeding roof caving, allowing the workperson to get alert. The process of installation of telltale is shown here. First, required length of hole is drilled in roof. The point anchor of the telltale are inserted in the hole and anchored as per the required length. The reading unit is thereafter installed. Reading is set at 0 mm. Any root movement between the top anchor and the reading unit anchor is recorded.